Good morning, first period. Hope y'all are acting appropriately. Hope you finished your warm-up. Before we get started on numbers 9 and 10, I actually need to go back and make a correction in number 7. So some of you guys might be mad because you were probably right the first time. But I just made a little error. And it's funny because me and one of the other teachers both made the same mistake. Anywho, so looking at this guy. So if my axis of symmetry is right here at 1.25. Alright, looking right here, just on the other side of the line. So that means the middle point is 1.25, right? Yes. And so looking at our x-axis, it looks like our x-intercept goes through at about, maybe we could call that 3.25. Alright, so 3.25 for our x-intercept over here. So the difference between these two is approximately 2 units, right? So that means I would need to go to this side, to the left of this, 2 more units. So, oops, that was ugly. So what is 1.25 minus 2? Well, just put it into your calculator and let's find out. So if I pull up my calculator, I did 1.25 minus 2 to represent the 2 units that we're moving to the left, and we get negative 0.75. Negative 0.75. So where is that in between? Originally I had told you guys C. I was wrong, and it is definitely D. Okay, so just remembering that that axis of symmetry makes it equidistant, like from this line, the points are equidistant on either side of our line. All right, so let's slide down now and talk about 9 and 10. So how does the graph of y equals 3x squared differ from the one y equals negative x squared? All right, so now that we know some of our properties of quadratics and we've tested over them too, you should be pretty good at this. So the graph of 3x squared, well, that's a whole number, right? So whole numbers, that make it wider or narrower? Yes, it makes it narrower. So he's going to get taller or skinnier. And that's all that's happening on that graph pretty much. But comparing him over here to negative x squared is almost our parent function, except he's reflected across the x-axis. So this is this guy, and our 3x squared would look like this. And again, you can always plug these into your calculator. So you'll see he's going to be a little skinnier, and he's going to look something kind of like that. All right, so let's look at our answer choices. So our new graph, he opens up. Yes, he's positive 3. So I'm going to eliminate both of those answer choices. And again, we just talked about whole number versus fraction. Remember that the fraction makes him wider or compressed vertically, and then the whole number, did I just say that right? The whole number will stretch it vertically or make it more narrow. So it is A. All right, and then on number 10, exponent rules. This one was actually on our test, if you remember that. So it looks like a fraction or division. Remember, whenever we are dividing exponents, look at the sign above the board for the quotient rule. The quotient rule is x of a over x divided by b is equal to x to the a minus b. So when we're dividing, we subtract our exponents. And the reason we do that is because let's say I had like x to the 4th power divided by x to the maybe to the 3rd power. So that would be x times x times x times x, all divided by x times x times x. So what is x divided by x? Well, that's 1, that's 1, that's 1. And I'm just left with 1x, or x to the 4 minus 3, which is x to the 1st power, which I don't really need to write. So that's the rules behind here. So I'm going to go ahead and erase that now. And let's talk about this problem. So first, remember our whole numbers will always play together. So 12 divided by 3 is 4. So I'm going to definitely eliminate these two guys. So I have 4 over 1, but I'm not going to put that 1 down there. Now let's look at our x's. So right here. So that would be x to the 6 over x to the 2nd. We subtract those, and I would end up with x to the 4th. All right. Looking at our y values. our y values right here. This would be y to the -4th minus a -6. Okay, so remember what do we call this thing right here? A double negative. What do we do to the double negatives? Make it a giant plus sign. All right, so I get -4 plus 6, which means I have y to the 2nd power. And then the last guy that we're going to look at is our z. All right, so that would give me z to the 2nd minus z. Oh, I'm sorry. Sorry about that. So that would give us z to the 2nd minus 3. Well, that would be z to the -1. Am I allowed to have a negative exponent up here on top? No, the answer is no. We don't ever have negative exponents anywhere. So how can I make this guy positive? Well, remember, we just move him down. So he'll just become down here, and it'll be z to the positive 1st power. So we're looking at D. Alright, so hopefully you guys got both of these correct. I would say to raise your hand if you got both of them correct, but I'm not here to witness it. So in my mind, y'all got them all correct, every single one of you, and I'm super proud of y'all. Stay on your best behavior for the sub. Get ready for the next note video, and I'll see you guys tomorrow.